So hello everyone, I'm your TA, and by this video I will show you how to draw your layout using the virtuoso. So if you're new to drawing a layout, you can see the full video and just follow the video. And then if you are already have experience on doing this, you can just skip the video, or you have confused with some of the step, you can just uh, skip this video to the timeline that you need to see. So first, I will explain why do we need to draw the layout. Layout basically is a physical representation of a circuit on silicon. So it will convert your schematic into geometric max pattern for fabrication. So it can link the circuit designer and process engineer, and then it will help them to communicate and through some design rule to make sure that your circuit can work normally in after the fabrication process. So this is like some flow. So first you will have to design a circuit, then you will need to draw the layout, and then you process into the on top of the silicon wafer. So uh okay, and then so since we are doing using a CMOS process, so this is some basic layout fabrication flow, and I believe the professor will tell more about this in the class. So I will just briefly talk about it. So this the max is to transfer the layout shape into the silicons, and there are some key layout. So like the active area, polygate, contact, and via and metal interconnect. Later, I will use the virtuoso to demonstrate again. In this part, I will just telling about some basic concept. So imagine this is a silicon wafer, and you need to define this area on top it. So like this is the annual max. So this is the here, this is the annual max, and then the active is the blue, and the poly is the red one. So this is the top view, and this is a cross section. So uh, when you're drawing a layout, you are from the top view to draw the max. So for example, if you are drawing an annual max, so what is you are doing? So you draw a small square in the virtuoso, and in real life it basically you want, so it will look like this. So the 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 black color in here is the it will cover by some photoresist. So the white color in here, you will have an empty space like here. So since unwell max is to implant undoping, so the blank side in here will be implant by some material. So it will have undoping in the wafer in here. So this uh, the purpose of max is so that you will define some area so you can do something around on it. And so this is our key layout concept for CMOS process. So the poly is to define the gate, and the if the intersection of poly and active is your MOSFET channel in here. So I mentioned the unwell is for PMOS device in here. And then if you don't have the unwell, implant, so it's just substrate, or you can also implant a P-well. So this is the unMOS, and context and via is here, so you can have interconnect with different layer, and the metal layer is for routing, so you can connect a lot of unwell based on your uh, you can connect a lot of unMOS, PMOS based on your design. Okay. So after you draw your layout, the one of the important thing is you need to pass the design rule. So they have two you need to pass. The first one is DRC. So DRC is guarantee that your circuit can manufacturably correct it. So so since we are using the 0.18 process, so the gate wide, so this is the gate wide, the minimum wide is 0.18 micrometer. So if you draw less than the size, so the DRC won't pass. The reason is because uh, when you are really fabricate um, the the layout you draw, if you are using most uh, if you are using very small or the very small size or the distance in here are too close, it might uh, cause some fabricate error. So we want to make sure that each NMOS and PMOS we are drawing is correct. So we have some rule that need to follow. And the other one is you need to pass the LVS. So the LVS is just checking the metal interconnect are correct. So later I also will show you how to run this too. And then, okay, so let's start. So I will also using the tutorial PDF that already uploaded to the EE class. And like this one. So first, you need to set up the environment, but I okay. So for this, I won't do it. I think this is pretty easy. So I just assume you have a mobile extern and you just need to download and you just connect it to this port, to this host and this port, and okay, and you just uh type your account and student ID in here. Okay, so let me open the mobile extern. So this this is uh this if your mobile exam show this, that means you have successfully logged in, and then use this command to connect to the server 42. Sorry. Okay, so you have successfully uh enter the server, and then so the when you are doing the first time, you need to uh create and edit this file to source the tool that we need to use, and you can use this command and just edit anyway. Then you need to copy paste this comment in here because I use a different software, so in here may be different from here. So, but you just need to Control C in here and then paste. How to edit it? First, you need to press the ESC button. Oh, wait, let me do it again. This and edit. Oh, sorry, you need to press I until this show this insert. Then you can just copy paste, or you type the code uh in the tutorial here. After that, you press ESC button and then type this. So you already finished the source and you need to exit and connect it again to the server. And then you can try to type virtuoso. To test if your step is correct. So if after you type virtuoso show this, that's mean uh you already successfully uh, source the software, the tools. Okay. Mhm. So and then so now we can use the cadence. So when you are doing your homework, first you need to create a schematic. So the schematic basically you just need to create your circuit, and after you create your circuit, you need to presim it. So you just test the functional is this correct or not? And after you doing the presim, you need to draw the layout. So and then you draw the layout and pass the DRC and LVS, and then you need to do the posim. So the posim is use the layout you draw to simulate a game, but it will have some parasitic effect because when you're drawing the layout, the different layout style will affect their parasitic performance. So you need to rerun again the simulation. So make sure that your design will still pass the spec you need. Okay, so let's do the schematic first. In this, I will try to simulate inverter. So first you need to um, okay, so let me reopen the server. Create a folder by here. After after you create the file, you just click, and then first you need to upload this file that we have already uploaded to E class. You can just drag, but sometimes you see that this upload is not working. I don't know why, but sometimes happen. So you can use this FileZilla client. You can download it and then type the host, uh, just like how you log in the mobile before. So type the host. The username is your student ID account, and your password and port is 22. So let me type it. Then press enter and then OK. So this is the file that you create in the server. So find the folder that you just create. This one, and then you just drag. So it successfully uploaded, and then you just refresh it. So that we finish. And then after you upload the file that we give you, so we need to change this. You need to change this. You need to type CD and your file name. And what is my file name? Test video. Okay, so make sure you run the simulation and open the virtuoso under this file project, and then you need to use this CD, and this is your file name, and then you can open virtuoso now. So first you need to add a new library. So this is the library manager, but you need to use this window. Okay, so file, new library, and then your name, file name like task, and then press OK. And you need to browse the technology file. Use this CIC 18. Then OK. Load successfully. So close. So in here you have your new library. And then first we want to create a schematic. So you can in library manager just select this task and then file new self view, and make sure this view is schematic, and then you want to build an inverter. So enter, click this, enter. So oh shoot. Okay. So then you press I, yeah, to add the instance, and then you browse, then you use this analog lib and then find unmost. So use this unmost 4, then this is your unmost, and then press I again to create PMOS. Okay. And then you need to edit the property. So press Q, then you can type your width and length. So so assume we use almost is 2 and the length is normally 0.18 U, and then for almost is wide. Press Q again, and then wide is 1 You need to write the unit, otherwise it will be meter. And then 0.18 U. Then you press W to connect the wires. So CMOS will be connected like this. Okay. Also, ESC is for this. ESC. Click it, ESC. Then you connect the body to the VDD for PMOS, and almost is to the ground. Okay. So press F to zoom in, and then you press P to put the pin. The pin is for the input output port. So my input is V in, and then sorry, press P again. The port is VDD. You can use this to turn around the pin. And P again for output, P out. And press I, G, and D for the ground. Okay. So press this to check and save. So no problem. And next, you need to create a symbol. So why you create a symbol is basically if you want to use this inverter again, you can just use the symbol. You don't need to build this circuit again. So it will be more easy. And then wait, let me see. So you create self view, and from self view, press OK, and the left. So this is your pin position, and try to adjust it by yourself and press OK. So you can try to draw it like here. So I will double click and change this label a little bit slow. Yeah, I think this you can just delete it. I'll type in here E and C. Then press D. No, press delete to delete this. And we can use this to create a triangle. And then use this like this and just try to connect it. You can try to draw it better. So finish. So why we drawing this inverter? So if you want to build a buffer, you can just press I and then use your library and use your inverter like this. So you can reuse the schematic that you just built. Okay. So, okay, you finish drawing a schematic. This is the first step. And then now we want to do the presim. So we will simulate it with HPICE. So we first will out export uh, the circuit file, and then we will run using a test bench to run uh, the simulation, and then use waveform to see your wave if correct or not. Okay, so first we need to, so after you draw the circuit, the schematic in here, and we'll use this window to export this, this. So choose your the library, and then you need to put the schematic that you want to export, and then press enter. Then change the name in here, env.spi. Okay, so this is so this fail. Let me see why. So the unit is wrong for W. So Q should be U, not UM. Just say J, and then export again. Okay, so when you see this window, that means you successfully export your file. Okay, so you can refresh, see your file in here. So the first thing you need to do is to change the NM and PM to this. Then save it. And next, you will need to create a test bench. So new empty file, pb test bench here. So I already type it. So first, you need to include your exported file. Then make sure the port name is the same. Wait, let me open again this. Okay. So this means you're calling this circuit. So this is just the uh, uh, parameter name. So you can name it whatever you want. And then the in VDD, and V out. maybe. I think the order will be the same. So let me adjust. So BDD. Okay. For the Spice code, and you can go online, Google it to learn more detail. So now I try to run the simulation. So if you show this, you just press enter, then type this code Spice. This is the test bench file name, and then using tb.list. So press enter. Okay. Oh, sorry, it's wrong. So no, you need to use O like this. So this means your code is correct. If if you don't change um, mm, if you don't change this, it will show something like this. So aborted means something wrong with your code, and you can open TB pointless to check it. So sometimes the mobile will fail, so I don't know why. So we just try to connect it again. So change the dictionary, and then we run it. It's a board. Okay, so uh, check it. The error message here. Warning or error will be showing here. So just change back and then save it and then rerun. Okay, so the presim is done. Then you will need to check the waveform by this. Uh, type this WV and then you can open the waveform from the file you just create. You can try to organize this uh, file. So this is W, and then you can show the P in and the P out. And you can basically this is the first homework, but you need to adjust the PMOS size, and that's it. Okay, so we finished for the presim. Then we need to draw the layout. Okay. Okay, so I will using different file to draw the layout. Let me reopen it. Yes. So okay, so wait. So if you want to, so sorry. So if you already have your schematic, assume the name is test2, and then if you want to create a layout file, you just click File, New, Self View, and change this to layout. Oh, sorry, my bad. So, okay. Oh, correct. So you just change this cell to your schematic file name and then change this to layout. Then you will create a layout file. Okay, so this test is only a schematic, and then you want to create the layout file. So you create a layout file in here, but it's still empty. Okay. So this is I already create the layout file to fasten up our video. So the layer we will use basically only this and maybe some metal ME2 and ME3 for the interconnect. So you can follow this tutorial to show a more detailed step, and I will basically just go through how to draw the layout. Okay, so uh, some short key. So the first uh you can click a layer in here and press R to draw a rectangular, and press F to zoom in, and you can scroll using mouse to zoom out. And then if you play A is for align. So you can align it, and then if you use A and then F3, you can decide uh the spacing. So if this one, so the distance in here will be one. And how you know? You press K to call this ruler. So this is one. And so if A and 3, we change it to 3 and use K. Okay. And another important thing, I think you can use this full select. Full select is mean it selected all the rectangular. And if this become empty, it's partial select. So it will only select one part. So if you F3 and then change this to 1, so it will be like this. Okay, so now draw the inverter. So in here I will draw PMOS white is 3 and then NMOS white is 1. So basically I will try to draw the diffusion area first. Just press R, and then because I want the PMOS white is 3, so I will partial select and then press A F3 to 3 and then adjust the white. So this is 3. Okay. Um, So for the this, okay. Next, draw the gate using poly, and then press R. And the gate, I want to draw 1.18 UM. So press A, then you can align. And so since the poly and the diffusion region have some design rule that you need to follow. So the distance in here need to be 0.4849, I think. So how you know the design rule? So you can open this technical file and then open this. No, this one rule with DRC file, and then you can read it here, like unaware rule, minimum distance, and it will have description. So if you first time drawing this 0.18 process, you can have take a look. Just read the layer that we use. So the for div also, and I think you can just div. So this is for rule for diffusion layer, and you can try to take a look. Okay. Okay, so the distance here need to be 0.49. So press A and F3 0.49. Boom, boom. Done. Then since this is we want to create a PMOS first, so we need to unwell L. For the upper part here is for the body. So we basically try to build something like this. And then so okay, so we can ignore this upper part first. And the distance in here should be 0.5. So click the unwell, press R and draw a big circle. And AF3 0.5. Align, align, align. I think you need to try to do it by yourself so you can have a feeling. And then we can draw a body. Okay, so if I want to align this part to my old part, you can use fully select and then press A, then A F3, no spacing. So you can align. So it's already aligned. Okay. So the if you use partial select, you also can align this with this. Okay. And then uh, I forgot to tell if you press Q, you can edit the property. So you can change the layer from diffusion to, for example, like this. So it will change the layer. And then you also can change the width and height. Cool. Okay. And then after build your this. So next layer, you need to create this PIMP. This is the I think it's the P plus implant. So 0 0.2, 0 0.2, 0 0.3, 0 0.2, okay. So if you want to delete the ruler in here, use Shift K. Okay. And so use this layer, create our AF3 0.2. And for this part is 0.22. So AF3 0.22. And this poly should align with this PIMP. Then I think we can draw um, this the body part. So I will use C to copy. You can copy in here and then AF3, AF3 to align it like this. And then next, drawing an IMP for the body. And just align it. So the distance for here is 0.18. 3, 0.18. Okay. So done for EMOS. Then you need to create a contact or interconnect. So the best scenario you can draw, you need to fill as much as via as possible inside the diffusion region, and the size is via is 0.3 times 0.23, and then the distance need to be 0. You can check the rule by yourself. So press R, and then you can click it, press Q, edit the width and the height. 0.23, 0.23, okay. So okay. 1, 2. Copy 3, AF3, 0.14, A. So if you forget to change this, the select part will become like this. So don't forget it. And then you can copy again and AF3, 125. Okay. Okay. So try to fill it. And since it's just for demonstrate, I will not do it very well. I just try to demonstrate. So basically the PMOS is finished, and we try to build the NMOS. So basically, you can just copy the body here first by pressing C, and we can stretch the poly pressing S. So let me shorten this first, and body. But you need to change this PI, this NIMP to PIMP. So you can just type it. Okay. Then since okay, so let me copy again. Unwell almost need a unplus implant, so we need to change this, and then the uh, and connect it. What's here? But the white we want to set it to 1, so here we change the height to 1, then this distance should be 0.2. So we can press S to stretch it first, then F3 to adjust the oh, adjust this, and you can try to put the contact again. Then F3, no, and just try to select it all and try to align it. And F3 on spacing, you need to let your poly align with this, and then this. Okay, so use poly to uh poly create a rectangle poly. Wait, where is poly? To create a rectangle like this, and use contact on top of it. So I will just copy just align, and the poly size need to larger than contact by 0.12. Okay, so the unknown's PMOS basically complete. The last you need to connect it by um, connect it by metal. So the interconnect will look like this. So use metal R, then trying to cover it according to the design like this, and then you can try to do it better. I think this won't pass because here is short. You need to have some distance like here. And the last one is to create the this M1 tags. So use this, then you press L to create a label, and then click in the end. So the label name is need to be the same as your uh schematic name. So BDD a out CSS. So just put it whether you need. Okay. So the layout is finished. This is for unMOS, sorry, for inverter. And maybe I talk a little bit how to, if you want to draw a NAND layout. So, okay. So NAND look like this. So if I want to do it, basically I will just copy the inverter in here. And then maybe I just try to delete the metal layer first. Okay. And since the NAND using two PMOS and NMOS, so I can just uh, delete the contact in here. Wait, I don't think so. First, you can just stretch it using S. Yes. Then you copy another uh, poly because you have two gate uh for two input NAND, and then and then uh uh and then you put a contact, but make sure the rule is passed. I just want to demonstrate. So you also need two input, and then and try to interconnect the the metal. So and I think this part you can figure out by yourself. I just want to give you a hint. So if you are already drawing the inverter and then you want to draw NAND NOR, you can just try to change the inverter in here, so you can take a look some rule. Okay. Next also, and okay, so that's it. And then for this drawing the layout, so you already draw the inverter. And the last part is you need to run the POSIM. Already draw the layout. Okay, so first you need to run the DRC and LVS to check it, as I mentioned before. So press calibrate, run DRC. and then change the rule using this file rule dot trc, and then run trc override. So this, yes. So if this blank, it means you pass. So if something wrong, uh, it will show some error in here. You can click it, the error, and try to read the error message in here and adjust it. Okay. And so the DRC is passed, then run the LBS. But before running the LBS, you need to export the schematic. So using the same step as before, export this, and using the schematic you just built, and then export it. And after you export it, so remember to change the unm and pm to un-18 and p-18. So I want to export it again. So calibrate, run LBS. Mm. The rules, you need to load the LBS rule. Then input the netlist. Need to use the circuit you just export to run. So if you see this smile face, that means your interconnect are correct. Okay, so if the LVS on DRC is done, the last step is to do the POSIM. So you need to extract the parasitic and then using HPIs to run the POSIM again. So how to run the PX? So here, still calibrate and run PX. So still use the rule in here. Oh wait, I need to export the GDS first. Okay, so you need to export the GDS first. It's in stream and select the inverter layout and change the file name in here. And you need to translate. Okay, no error. So I will do it again. So after export the GDS, open the layout file again, and then calibrate EX. Then rule, select this RCE, then input for the layout. In here, you select your GDS. So where is my GDS? GDS, and then for the netlist, you need to select your spice file. So SPI, and then the output, you need to change your name here, and then SPI, run, boom. So if show this windows, it means it's correct. And last, you need to run the pull sim, and how it run it is basically the same, but the thing you only need to change with presim is the circuit file you include. So, so before the presim, this include file, it should be like inverter point SPI, but now since your export file is um, here, the thing here you type, so you just need to change the include in here and rerun the POSIM and rerun the simulation, then you finish. Okay, so here you can see the export file it create. And okay, so let me run it. So if your the presim you circuit file you include should look like this, and then you change it to PX file, and then use the test bench, but my test bench has different name, so test dot test. Ah, shit, it's twice. And it finished, and then try to open the wave view again, and you can see your design is correct or not. And I believe this is, I don't think, I think this is it. This is it. And then if you have any question, you can ask me, and I hope this video can help you draw the layout more smooth. But you need to try to do it by yourself, and the way you're familiar with the software is just keep doing wrong, and you will learn learn a lot. And okay, that's it. Thank you. How to turn on.